Okay, let's say we know the mean value and standard uncertainty of some measurement, and we want to work out the confidence intervals. So we want to know what range are you 50% likely to be in, 95% likely to be in, or whatever. So let's do a particular example. Let's imagine we have a furnace, and it's got a temperature of 422 Kelvin on average with a standard uncertainty of 8 Kelvin. And we want to work out what are the confidence intervals. What range of temperatures can we be pretty sure that the temperature is always going to be in? Remember, it's not just within 8 degrees of 422 because it's going to be a normal bell curve distribution. It's quite likely to be in that range, but there is going to be some chance of it being much further out. And that's what we're trying to compute. Now, if you remember, the equation for a normal distribution is this one. So it's basically e to the minus how far you are from the mean squared with sigma on the bottom. So mu here will be the mean, 422, and sigma will be 8. That's the standard deviation, the standard error. And what we're going to try and work out is, let's say we want to work out what interval are we 95% confident we'll be in. We're going to work out how wide a range of furnace temperatures do we have to pick so that the area between them is 95% of the total area, or 0.95. So how wide must this be to include 50% of the area, 80% of the area, 95, 99, whatever percentage we're after? Okay, so how are we going to do that? Well, as you know, to find the area under a curve, you have to do an integral. So what we're doing here is the integral for a certain distance either side of the centre. So from minus n standard deviation, standard uncertainties to the bottom, and plus n standard uncertainties to the top, and we're going to integrate this, just the normal distribution. So we're going a certain number of standard errors this way, and a certain number of standard errors this way, and we want to integrate over that. Now, unfortunately, this equation can't actually be integrated in so-called standard or closed form. There is no equation you can write down which is an integral of this. You have to work it out by using a series expansion or some other numerical method. But luckily it's a very common expansion we have to do, and so a whole bunch of computer programs do this. It's called the error function, ERF. And it turns out what you need to do to work out what fraction of the time you're going to be within n standard errors of the centre, n sigma from the centre, is you divide n by the square root of 2 and calculate the error function, ERF, of that. So let's say we wanted to work out what fraction of the time we're within 1 sigma, 1 standard uncertainty of the middle, which is 8 away from 422. We divide 8 by the square root of 2, which is 0.707. And we could type it into Excel. So we can type ERF 0.707 here. That's the error function in Excel, and it gives us about 68%. In Python, we need to import the math library and then math.erf 0.707, and it gives us the same number, as you would hope it does. So, you're going to be within 1 standard uncertainty of the centre 68% of the time. What that's telling us is this area, which is the area from 1 standard uncertainty below the mean to 1 standard uncertainty above the mean, in this case 8 below the mean, 422 to 8 above the mean. That blue shaded area is 68% of the total area under the normal distribution. And it's quite easy to work out a table of these things. Here I've done it in Python, and you can see that 1 standard deviation, 1 sigma away, you get 68%. By the time you're up to 2 standard deviations, you're at 95.4%, 3 standard deviations, you're at 99.7%, and so on. There are basically some numbers you should probably remember here. You're going to be within 1 standard uncertainty of the mean about 68% of the time, and about 95% of the time you're going to be within 2 standard uncertainties of the mean. If you want to be more certain, you can go up to 2.6 or 3 standard uncertainties, but normally these are the 2 numbers that are most important to remember. So in this case, we're going to be in the range between 1 standard uncertainty below the mean, which is 422 minus 8, i.e. 414 Kelvin, to one standard uncertainty above the mean, 422 plus 8, which is 430 Kelvin. We're going to be in that range 68% of the time. So we could see our confidence interval with 68% confidence. We can say we're going to be between 404 and 430 Kelvin. 68% is not a very confident number. A better number might be 95%. That's most of the time. As we said before, 100 would be better, but you're never going to get 100. So in that case, you have to be 2 standard uncertainties below to 2 standard uncertainties above, which is 406 to 438. So our confidence interval, 95% confidence, we can say the furnace will have a temperature between 406 Kelvin and 438. And you could go up to even 3 standard deviations away, in which case you've got 99.7% confidence that's in the range 398 to 446.